we'll do some examples about applying these sine and cosine ratios to find missing lengths in a triangle. So in this example right here, we got a right triangle. We know the hypotenuse is 14, and we know this angle has a measure of 26 degrees. So I'm going to choose that angle to be our reference angle. Could I have chosen this top angle? Sure. But it doesn't matter which angle we choose. I'm just going to choose this one because it was given to us. So this will be our reference angle. So now I'm going to label all of the sides to help us use these trig ratios. So this 14 is the hypotenuse. This x is not touching this angle, so it's that opposite side. And y is the adjacent side. So we're going to use trigonometry to find the values of x and y. So let's start with finding x. Alright, so x deals with this opposite side, so we need a trig ratio that deals with the opposite side. We're going to compare it to the hypotenuse. So then we have an unknown and a known value. That trig ratio is sine because sine of an angle is the opposite side over the hypotenuse. So that means sine of this angle, 26 degrees, equals the opposite side, which is x, over the hypotenuse, which is 14. Now we can multiply both sides by 14 to get 14 sine of 26 equals x. And then we'll use our calculators to calculate x, so we type in 14 sine of 26. And again, go to the next page in this module to find how to use your calculator to calculate trig values like this, okay? So when we use our calculator, we get 6 point, let's just say 1 for x. I'll use squiggles to indicate we rounded. This is an approximation. There. Now we can use Pythagorean theorem to find y. However, for the sake of practice, I'm going to use another trig ratio. So let's use y. This time, we're dealing with the adjacent side. We're going to use the hypotenuse as well. So the trig ratio that deals with the adjacent side and the hypotenuse is the cosine ratio. So we write cosine of 26 degrees, I have a reference angle, equals the adjacent side, which is y, over the hypotenuse, which is 14. Multiply both sides by 14 to get 14 cosine of 26 equal to y. Then we do 14 cosine 26 in our calculator. We should get 12.6 for y. That's how you can use, and I rounded, so I guess I should use, but that is how you can use trig ratios to find missing lengths in a triangle. Now let's take a look at this next example. Given sine of a equals 3/5, what is cosine of a and tangent of a? So a few of these show up on your homework, or in big ideas, I should say. So let's see. You know that sine of an angle A equals the opposite side over the hypotenuse. So let's draw a right triangle. Right triangle. Let's choose an angle to be the reference angle. It doesn't matter what angle you choose as long as it's not the right angle. So I'll choose this angle, call this angle A. That means sine of this A. Actually, let me back up. Let me label these sides. So this is the hypotenuse. This is the adjacent side. And this is the opposite side. Okay, so this sine ratio, we know that sine of A is the opposite divided by the hypotenuse. And we know that ratio is 3/5, or some multiple of it. we'll find the triangle that is in reduced form. So this means that this opposite side has length 3, and the hypotenuse has length 5. To find the adjacent side, you could use Pythagorean theorem, or you might recognize that this is a Pythagorean triple, which means that this adjacent side has length 4. So now you have a triangle, and now we have the adjacent side, so we can find cosine of A and tangent of A. So cosine is the adjacent side over the hypotenuse, which is 4 over 5, or 0.8, if you will. Tangent of A is the opposite side over the adjacent side, which is 3/4, or 0.75. So that's how you go about solving for those and finding those ratios. So first, start by drawing your triangle, and you have to know what sides these numbers correspond to. So our sine ratio is opposite over hypotenuse, so we knew that the opposite side had length 3, and the hypotenuse had length 5. That's kind of the key for these types of problems. Lastly, we're going to deal with an angle of depression example with a person skiing down a hill. So, we've dealt with angle of elevation, but not angle of depression, which is why I threw one of these into the notes. So, okay, we're skiing downhill. As an altitude of 800 feet, that means it's 800 feet from sea level, so straight up. So this is 800. The angle of depression is 15 degrees, and you're trying to find find the distance x you ski down the hill. So this is your hill. So this is our distance x. Okay, now this angle of depression, that's like, okay, imagine you're outside and you see a squirrel on the ground. Your angle of depression is, okay, imagine you're looking straight forward, and then the angle of depression is how much you have to turn your eyes downward to get from looking straight forward to down at the squirrel. So for us, that'll be, if you draw this line here, it's like you're looking straight ahead. The angle of depression is from looking straight ahead down to the ground. So this is a 15-degree angle of depression. This altitude is still 800. So now let's take a look at this pink triangle with the right angle up here. Okay, so let's say this 15 degrees is our reference angle. Let's label our sides. So this is the adjacent side, this 800 is the opposite side, and this x is the hypotenuse. So we're looking for the hypotenuse, which means we need to use sine or cosine. We're given the opposite side, and since we only want to have one unknown variable, we need to use this opposite side because we don't know the adjacent side. So we need to use the opposite side. So we need a trig ratio that deals with the opposite side and the hypotenuse, which is sine. So we say sine of 15 degrees equals the opposite side, which is 800, divided by the hypotenuse, which is x. Now multiply both sides by x, and then to get x by itself, divide both sides by sine of 15 to get x equals 800 divided by sine of 15. So now you can use your calculator. 800 divided by sine of 15. Let's see, x is about, we'll round here, 3,091 feet. So that's about how far we traveled down the hill, with an angle of depression of 15 degrees and an altitude of 800 feet.